Hey everybody, welcome back to a new video. Today we are looking at a new power station from ALLPOWERS. This is their R1500. Now previously on the channel I reviewed their larger R2500, so this is the little brother to that power station, and there are a few unique things about this power station versus other models in its same size category. Now the first unique thing about the R1500 is actually the expansion battery. If you look closely, you have USB ports, a display, and also a 12-volt output. So instead of having an expansion battery with no connections at all, when you connect this up to the main head unit, not only do you get double the capacity, but you get additional outputs. The next unique feature has to deal with the solar charging. For example, this allows up to 95 volts open circuit. So connecting solar panels in series is really easy on this power station, and you can actually get the full input when they're connected in series. You can get up to 650 watts charging input, which is a little bit higher than the average middle-sized power station. They usually get around 500 to 600 watts, so it's nice to see that extra 50 watts. Now lastly, this power station actually has two wireless charging pads. Now why do I mention that? Well, because most power stations don't come with wireless charging pads anymore, and if you want to charge your phone wirelessly without connecting a cable, it's still a nice feature to have. Now taking a second to go through the other features and specifications, this does have a lithium iron phosphate battery rated at 1152 watt hours. For the inverter size, it has an 1800 watt pure sine wave inverter. We'll be testing that with a max load test and also surge capacity testing to see how it handles induction loads. This does have fast internal AC wall charging and also supports UPS functionality with a cutover time of 15 milliseconds. This has smart app connectivity. It has two USB-C 100 watt power delivery ports and also a 12 volt socket for your DC output. Now what about pricing? It's been super competitive lately. This had an MSRP of $899, but with the recent price drops going throughout the entire industry, this is down to $469 on their Christmas sale, which is the same between Amazon and their website. Now I will say they've provided a discount code for you guys, my viewers, that if you use that on their website, I'll include that down in the video description, you can get the price down to $422 or about 36 cents per watt hour. That is a crazy price. Now, if the ALLPOWERS R1500 happened to spike your interest, I'd recommend sticking around for the remainder of the video where I go through all the in-depth testing that I've done on this power station so we can see how it performs versus the advertised specifications and outputs. These always perform a little bit differently than advertised, sometimes in a good way, sometimes in a bad way, and my job here is to show you guys those honest results so you guys can make an educated decision on the R1500. So first, we're going to test the AC inverter and its output to see how it performs. Then we'll do the DC testing with the USB ports and the 12 volt socket to see how many watts we can pull from this 12 volt socket and to see if the USB ports perform properly. And then we'll be doing a bunch of charging demos to see how the solar charge controller and AC charging actually function. Like, does it support pass-through charging, or can you charge with AC and DC input at the same time? We'll be testing all of that. Now before jumping into the testing on the AC inverter, I thought I'd show you the outlets on the front where you plug in your appliances. Now these are NEMA 20 amp receptacles. There are 4 of them. They all have these covers. Now remember, the AC inverter is good for 1800 watts output continuous, and it's rated for 120 volts. So we'll be testing that here in a second. To turn it on and off, you press this button here. You get a green light indicating that it's enabled and a couple icons on the screen. So let's see how it actually performs. How does the R1500 perform under a max load test? I started by setting up an 1800 watt load on the inverter. After the test had been going for a few minutes, I moved my camera over to check my oscilloscope. It was showing a pure sine wave output, and I measured 122 volts at 60 hertz. After about 8 minutes of running that 1800 watt load, the cooling fans were up to their full speed. I measured 54 decibels with my sound meter at 3 feet away. So these fans are right under the 55 decibel mark for being too loud. Next, I measured the air exhaust temperature with my thermal camera. I saw a peak of 108 degrees near the exhaust fan ports, so they do a pretty decent job moving air through the inside of the power station. My stopwatch soon hit the 15-minute mark and the power station passed the max load test without shutting down the inverter. Now how many more watts will the inverter allow you to pull before it actually overloads? I turned up the load from the previous test till it got up to about 2000 watts and the inverter shut off. So it's good to see the inverter does have a bit of room if you need to pull slightly higher than 1800 watts before it shuts down. So in the next section of the video, we'll be testing the surge capability of the R1500 inverter. For this test, I have this extension cable that's modified so I can put a clamp meter on the hot lead, and this clamp meter measures inrush current. Now each of these induction loads pulls a bunch of surge current as they turn on. I have a 10 amp air compressor, a 12 amp vacuum, and a 15 amp table saw. So we're going to see how much current this can handle before it overloads the AC inverter. So you'll want to keep an eye out on the screen right here. It will show the maximum amperage as the device turns on. So 3, 2, 1. So it looks like we measured 20.86 amps as the air compressor turned on. So now we're ready to test the 12 amp vacuum. Pay attention to the numbers on the screen. 3, 2, 1. So the vacuum pulled a total of 24.39 amps. So next we will be powering up this 15 amp table saw. So let me get the camera set up. 3, 2, 1. Okay, it looks like it failed to power it up. It stopped right around 23.82 amps. So just a quick recap on the AC inverter surge testing. We had no issues starting up the 10 amp motor on the air compressor. We had just a teeny bit of a delay with the vacuum turning on. Remember, that was right around 24 amps. And it failed to start up the large table saw, failing at about 23 plus amps. So I would not recommend going with a larger surge load on the R1500. Maybe just stick with your medium loads and you should be fine. So in the next test on the AC inverter, I want to test the UPS functionality on the ALLPOWERS R1500. Now in the user manual it states that it has a 15 millisecond cutover time, so we'll be testing that with my oscilloscope. Now let me briefly explain how UPS mode works. Whenever you are charging from the wall with AC power and you have the AC inverter turned on, it takes grid power and passes it straight through to your loads. Now whenever it senses grid power going out, like a power outage, it will automatically swap over to the internal inverter within 15 milliseconds, so your devices keep running. Now it's important to find out how fast that actually is, because sensitive devices like computers often will shut off if it's not fast enough. Now I like to do this test when the PC is under a stress test, meaning the power supply is pushed to its limits. So you can see that green screen means we are running a stress test on the PC, so let's go ahead and test the cutover. So let's record the first cutover. 3, 2, 1, record. So if we look, this is where the power cut out. Then we had this flat line where there is no power, and then where the power resumes. And if you look between these two cursors, it gives us a measurement of 11.9 milliseconds. So this did perform faster than advertised. So we'll do a couple more tests just to verify it works properly. So UPS test, 3, 2, 1. Looks good, the lights are still running, same with the computer. Final UPS test, 3, 2, 1. Yep, everything looks good. In my next test on the AC inverter, I want to plug in my outlet tester to see how the inverter outlets are wired. Do they have an open or floating ground, or is it a bonded ground? So I've enabled the AC inverter and plugged in my outlet tester, and you can see the middle light is enabled, meaning that it has an open or floating ground. Now this is going in and out due to my camera shutter speed. In real life, this is on all the time. So I've just connected in the AC wall charging cable, and the outlet tester is showing that it is now grounded and properly wired. So whenever you're charging or in UPS mode, the power station does pick up ground. Now you can hear a very slight interference in the background, and that is whenever the power station is charging from AC power, there is a slight electronic interference that you can hear. How much usable capacity should you expect from the R1500 inverter? The internal LFP battery is rated for 1152 watt hours of capacity. When draining the power station down until the inverter shut off, I measured only 950 watt hours of usable capacity. This result is 82.4% of the advertised capacity, which is a little below my goal of at least 85%. I would have liked to see a little bit more usable capacity in this test. Next, how much power is used as the AC inverter is enabled and sitting idle? I started with the power station at 100% state of charge and left the inverter turned on for 12 hours with no load, and when I came back it had dropped down to 83% state of charge, meaning the inverter had used 17% of the battery after about 12 hours, or only 1.4% per hour. This idle power usage is pretty average compared to similar sized models. Does the power station inverter create any noise or interference? I measured over 2000 millivolts of EMI using my dirty electricity meter, so the inverter produces a pretty high measurement of EMI. But is that level actually audible? Plugging my guitar amp into the inverter, this is what it sounded like. So comparing the inverter output to wall power demonstrates that the R1500 does produce a slight audible noise on the inverter. You'll see later in the video that this unit also produces interference while AC charging. In my final test, I wanted to see how long the battery could run my full-size basement refrigerator. Keeping your food from spoiling during an extended power outage can save you hundreds of dollars. Starting the test with the power station fully charged, my fridge was using about 117 watts to run the compressor. Checking in 13 hours later, the power station had just barely turned off. Turning it back on revealed that when it hit 5% state of charge, it shut off the inverter, leaving a little bit of reserve power. 13 hours is a pretty decent runtime for a medium-sized power station like this. Okay, so we got all those AC inverter tests out of the way, and before jumping into the next section of testing, I want to remind you that at the end of the video, we'll be covering a summary of the performance of this power station right after I put it through my power station grading system. So if you want to see that, stick around to the end of the video. So let's jump into testing the 12-volt cigarette port and the USB ports on the R1500. Now there's one switch right here that turns on both these outputs, so they are not separated between 12-volt output and USB ports. They're controlled by one switch. Once you turn it on, you have a light and you can see the icons enabled on the screen as well. Now using my battery load tester to measure the voltage output of the 12-volt socket, you can see it's regulated at around 12.5 to 12.6 volts. Now in my next test, I want to see how many watts we can pull from the 12-volt socket before it shuts off from being overloaded. We're pulling 125 watts right now. Let's turn this up slowly to see how much power we can get. 128, 130, okay, 131 watts before it shuts off from being overloaded. Now, unfortunately, we only have one option for 12-volt output. It's this cigarette port. So if you want to power two devices at the same time, you'll have to purchase a splitter like this. Just remember, you're going to be limited to 130 watts before the output is overloaded. Now in the next set of tests, I want to use my USB tester to test out each one of these USB ports to make sure that they can get the full power output. Now there are a total of 4 USB ports to connect up your mobile devices. You have 2 100-watt USB-C power delivery ports and 2 fast-charged USB-A ports. Now testing the first USB-C 100-watt port, you can see we're getting 105 watts out from the power station to this power bank. If we look at the tester, it does show power delivery 3.0 at 100 watts, which is around 20 volts at 5 amps. And we are charging this little power bank at 98 watts, so it is working properly. Connecting up to the second 100-watt port, we are seeing the same results, right around 104 watts output, power delivery 3.0 at 100 watts, 20 volts, 5 amps, and we are also charging this power bank at 98 watts. So both of these ports work properly. Now what about the USB-A ports? I've connected up to the first 18-watt fast charge port. We are seeing quick charge 2.0 protocol at 12 volts, so 12 volts at 1.5 amps or 18 watts. You can see we are charging this power bank at 18 watts. Connecting up to the second fast charge port, we are seeing similar results. Quick charge 2.0 protocol at 12 volts, so 12 volts, 1.5 amps. We are also charging this power bank at 18 watts, so both of those ports work properly. In the next test, I like to make sure that you can use all 4 USB ports on the power station without any of them losing power. So I'm charging my Anker C300 at 100 watts. I'm charging my Energizer 320 at 100 watts. I'm charging this power bank at 18 watts using a fast charge port, and my wireless microphone kit is charging at about 5 watts. So you are able to use all ports at the same time, and we're pulling around 231 watts. Now, how much power should you expect if you're trying to use all the USB ports and the 12-volt socket at the same time? So with us maxing out the 12-volt output and having 4 different devices connected to the USB ports, we're pulling around 360 watts. So a reasonable amount of power for this mid-sized power station. Now, I think it's important to mention that the R1500 has 2 15-watt wireless charging pads on top of the power station. So if your phone supports wireless charging, you can just set it on there and it will start charging up. You just want to make sure that this DC switch is enabled to turn on both of these pads. And yes, I've tested both of these and they both charge up my phone. How much usable capacity can we expect as we discharge the power station through the DC output? The R1500 has an advertised capacity of 1152 watt hours. And while draining the power station completely down until the DC output shut off, I measured a total of 1003 watt hours. These results were 87.06% of the advertised capacity, which is right on par with other models I've tested. Now, how much idle background power is used while the DC output is enabled? I started the test at 100% state of charge with the DC output enabled, and checking in after 12 hours, it was still at 100% state of charge. So it seems the DC output uses such little power at idle, it isn't registered on the screen. Well, now that I've completed the DC output testing on the R1500, there's just one thing that I want to discuss just to make sure you guys understand. So this port right here is limited to 130 watts. So if you want to power multiple devices, make sure you don't go over 130 watts. And if you want to power like a diesel heater or a 12-volt air compressor, you're going to have a hard time doing that because they pull over 130 watts and this is going to shut off. Now, luckily, you do have an expansion battery that's available for this unit that adds an additional 12-volt socket. So at least you can power two things there. But I will say, as these power stations keep getting better and better, one thing that I'd love to see upgraded is this 12-volt socket here. I'd love to see these upgraded to 15 amps output or 180 watts. I want that to be the standard. We are seeing many upgrades in other places, but you have this large DC battery here and you can't get that much DC output. So wouldn't you guys love to see a 15 amp output? Make sure you guys throw a comment down below if you want to see that. In the next section of the video, we'll be doing some charging demos on the ALLPOWERS R1500. We'll be testing to see how fast it charges with AC input. We'll be testing the solar input and also answering questions like, does it support pass-through charging? Does it accept dual charging? And does it have adjustable AC charging? Let's jump into it. Now in the box, they do include an AC wall charging cable, but if you want to charge with solar or do car charging, you will have to purchase those cables separately. On the left-hand side of the power station, you'll see both of the charging ports. This one right here is for the DC input. This is an XT60 port, supporting a voltage of 12 volts all the way up to 95 volts with up to 13 amps or 650 watts. I really like that this has a higher voltage than most of these smaller power stations. 95 volts is really good. Over here, you have your AC input. Now, if you press this, you can open it up and see both of those ports. Now, I want to start with the AC charging first. If you open up the Smart app, you can see there are 3 different charging speeds. You have fast mode, standard mode, and mute mode. I want to see how many watts we can get on each one of these, starting with fast mode first. So with the AC wall charging cable connected, I've been letting this go for about 5 minutes now. It's set to fast charge mode and we're getting around 874 watts input. I was expecting a little bit faster charging than this, so we'll have to see what the other 2 modes do. So now I've set the power station to standard charging mode and we're actually seeing the same charging wattage, right around 874 watts. So there might be a bug here not allowing it to charge at the full fast mode because the standard and fast mode actually have the same charging speed. But let's go ahead and test out the final charging mode, which is mute mode. So with the power station set to mute mode, you can see we're charging at 252 watts input, and the fans have really backed off right now. They're just barely running in the background, and that's the benefit of this mode. So if you don't want to make any noise while charging, you can set it to mute mode and it charges a bit slower, but there is no fan noise. Now, speaking of noise, whenever this is AC wall charging, you'll hear a little bit of interference that my camera's picking up. This noise is not audible to my ears. It's only audible to sensitive devices like my camera, so just be aware whenever this is AC wall charging, you might have some sensitive devices that pick up on that noise. Now, just to demonstrate that, I'm currently AC wall charging and you'll hear that background noise, but the second that I unplug this, it will stop. In the next set of tests, I want to test the DC input on the R1500. Right here I have my adjustable power supply. This is capable of 1200 watts output, so we should easily be able to max out the input for this device. Let's first test at 13.8 volts to simulate car charging. So my adjustable power supply is set to 13.8 volts and we are seeing 8.5 amps into the power station. I do have this set to 15 amps, so it is being limited to 8.5 amps. And on the screen, we're seeing 118 watts coming from this precision power supply. And on the power station, we're seeing 116 watts, so it is fairly accurate. Now, if this was completely empty, charging off a 12-volt battery like this, it's going to take around 10 hours to completely fill up the power station. Now, I've bumped up the voltage on my adjustable power supply to 25.5 volts, and you can see that it's still being limited to 8.5 amps, even though we have this set to 15 amps. So the power station needs a little bit higher voltage to get the full 13 amp input limit. We're seeing about 217 watts from the power supply and around 216 watts going into the power station, and this would take about 5 hours to charge the power station if it was completely empty. Now I've slowly bumped up the voltage up to about 34 volts, and that's when it finally got the 13 amp input limit. So you will need about 34 volts in order to get the full amperage input limit. We're seeing 456 watts from the adjustable power supply and around 452 watts into the power station, so you get much faster charging as you get the voltage above 33 volts. Now, if you remember, this power station has an input limit of 650 watts, and I've slowly been raising the voltage of this adjustable power supply to get close to that. So right now we're at 54, almost 55 volts and 11.5 amps, and we're seeing 636 watts. So you're going to need somewhere around 50 to 55 volts in order to get the maximum power of 650 watts input. Now in my next test, I want to see if this supports dual charging with AC and DC input at the same time. So I have the AC charging and the DC charging connected, and we're still charging at the full 630 watts from DC input. And you can see on the screen, we're getting around 1429 watts, and it's still rising. So it does support dual charging with AC and DC input at the same time. So I've let this go for a minute here, and it looks like we're going to top out right under 1500 watts. We're getting 1489 watts with dual charging, so that's what you should expect to see if you have this set to the fast charge mode with AC and DC input connected at the same time. Now I also wanted to make sure that this supports full pass-through charging, the ability to use the USB ports, the AC inverter, and the DC output at the same time as charging. So I have both charging options connected, so AC and DC input, and we are able to power USB, the AC inverter, and DC output at the same time. So this does support full pass-through charging. So in the next test, I want to do some solar testing on the ALLPOWERS R1500. Now these solar panels right here, these are actually 200 watt solar panels. Usually I have 5 of them wired together in series, but because this has a 95 volt limit, I can only use 4 of them in series. So I do not have that 5th panel connected. Now for the solar conditions today, it is a winter day around 30 degrees. It's later in the day because the clouds just barely cleared out, so I have some good conditions. It's been really cloudy lately, so I'm still expecting pretty decent power, and with the sun being so low in the sky, this is a pretty good angle. So let's check the voltage open circuit before connecting it up to make sure it's under 95 volts, and then we'll plug them in. So measuring with my voltmeter, you can see we're getting 92 volts open circuit, so right under the 95 volt limit. Now just FYI, the power station was turned off when I connected the solar panels, so it does automatically turn on if you plug in solar. So taking a closer look at the screen, you can see we're getting 640 watts charging input. Now this is right under the limit of 650 watts, so we are getting basically the maximum solar input on this power station. Now getting 650 watts on a power station this size is actually pretty good. If you remember, the Bluetti AC180 gets 500 watts, the Anker C1000 gets a little bit higher at 600 watts, and the EcoFlow Delta 2 also gets 500 watts. So this is a little bit higher than the average power station with 1000 watt hours. Now some of you may be wondering, well, how do you have 800 watts of solar panels connected up to the power station even though it only allows 650 watts? Now this process is called overpaneling. As long as you don't go over the 95 volts, you can actually have more wattage connected, and you'll be able to get more solar charging throughout the day, especially on days that don't have good solar conditions. So I always recommend to overpanel your power station just a little bit so you can hit that peak input throughout more of the day. And that is totally fine here because we are staying under 95 volts. In my final charging test, I wanted to see if this model supported having solar panels connected 24/7. Sometimes in the early morning hours when solar voltage is low, certain power stations will have a low voltage beep or alarm indicating it can't charge yet. When I tested this out, there weren't any annoying beeps or alarms early in the morning. It just started charging as the sun started hitting the panels, so no issues having solar panels connected to this all the time. Now ALLPOWERS also sent out the B1000, the expansion battery that works with the R1500, so I thought I'd cover a few details of how this expansion battery works. Now the B1000 is pretty much the same exact size as the ALLPOWERS R1500. It has the same capacity battery. It's an LFP battery rated at 1152 watt hours of capacity. You'll notice that it's just missing the AC inverter. You still have the USB ports and the DC output, so this is kind of like a DC power station. It comes with the user manual and also this AC charging cable and the cable that connects them both together. Now when it comes to charging the B1000, you'll notice that there's actually a charging port on the side of the battery, which is different than most other power stations. Their expansion batteries don't have a way to charge them, so it's nice that you can charge this via 600 watts of AC input. Now note there is no DC input, so there's no solar or DC charging on the expansion battery. It will charge up when it's connected to the main head unit, or you can charge it independently right here. Now it's important to note that this power station does average out the state of charge between the main unit and the batteries. For example, before I connected up the expansion battery, the main power station was at 80% state of charge. The battery is at 100% state of charge. And when I connected it up, it averaged it out to 90% state of charge. So it is good that it does some sort of smart calculation to the state of charge of the main system and the batteries that are attached. Now I briefly tested both the 12 volt output and the USB ports. They do function exactly like the main power station. You can get around 130 watts from the 12 volt socket, and both of these 100 watt ports provide 100 watts, same with the fast charge ports at 18 watts. So the DC output functions just like the main power station. So I've connected in a 1400 watt load to the AC inverter on the main unit, and you can see that the expansion batteries help powering this load. We have about 500 watts coming from the expansion battery into the main unit, which is splitting up that 1400 watt load. So now I wanted to demonstrate connecting the AC charging cable to the main unit. We'll actually charge the main unit and the expansion battery at the same time. We're getting almost 1500 watts input, and 400 of those watts are going down to the expansion battery. So if you want to charge both with AC input, you're gonna have to connect to the main charging port. Now in my final test on the expansion battery, I wanted to do a full capacity test to see if the efficiency got any better. Now together, the rated capacity is 2304 watt hours. I discharged this down at a 0.2C rate, and I was able to pull 2000 watt hours exactly, which is 86.8% of the advertised capacity, which is a little bit improvement of just using the power station on its own. Well, now that I've completed all the performance testing on the R1500, I have a few other details that I want to cover before talking about my power station grading system. Now this comes in at 36 pounds, and the extra battery is just a little bit lighter because it does not have the actual inverter or DC charging system. Now as for the size and build quality, it's just a little bit bigger than some of the other power stations in this same size category. And if you look through these vents here, you can kind of see that there's more open space. So I don't know if they've designed it just to have better airflow, but just be aware it is a little bit more bloated or bulky than other brands that have tested with the same size battery and inverter combo. Now ALLPOWERS does offer a 5-year warranty on this. I don't have experience with ALLPOWERS customer support because I've never had one of their units die on me during my testing. But if you guys do have experience with their customer support, make sure you leave a comment down below whether it's good or bad, because I always like to get that feedback so my viewers can see what their customer support is like. Now you do have the ability to use the ALLPOWERS Smart app to connect to the power station via Bluetooth or Wi-Fi. Now when you're connected to the device, you have the ability to adjust the AC charging speed. You can turn on and off the outputs remotely, and you also have the ability to adjust the eco mode settings, so it will shut off automatically after a certain given amount of time. When I tested this, I was able to connect with Bluetooth, and the range seemed pretty decent. Connecting via Bluetooth is really easy. Now connecting via Wi-Fi is a different story. The process is not intuitive at all. I would recommend that ALLPOWERS updates their smart app so it's a little bit easier to use when you are trying to connect via Wi-Fi, because I was unable to do that on this device. Now we're finally to the portion of the video where we can put this through my power station grading system. It's available on my website. You can actually download a local PDF if you want, but you guys know the drill. There are 20 different performance requirements. Each one's worth a half point for a total of 10 points, and I have yet to get a power station with a perfect score. Let's see how this one does. So up on the screen, you'll see the results for the R1500. It missed out on 3 different items. The first one being it did not get 85% of the AC capacity. It also had noise on the AC inverter, especially when charging, and it did not support over 150 watts of DC output. So 1.5 points down, got a total score of 8.5 points, or a final grade of a B, which is pretty decent for a budget unit like this. So after doing all this testing on the ALLPOWERS R1500, what are my final thoughts? Maybe some pros and cons? Well, let's go through some of them. Now starting with the good things first, if you're looking for a really affordable power station that still has some of the premium features, the ALLPOWERS R1500 might be a good option for you. The price is really low. Through their website, it's $422 if you use the discount code that's down in the video description, which is right around 36 cents per watt hour. If you're looking for solar panels in series, this is also an advantage because you can put up to 95 volts into this unit for solar panels, so you can connect up to 3 or maybe even 4 depending on the solar panels in series. And I like that you have a little bit of boost of extra solar power at 650 watts when some of the competition only have 500 or 600 watts, so a little bit of extra power there. Now, if wireless charging is your thing, then you also have 2 of those wireless charging pads on the top of the power station. And let's not forget that the expansion battery itself has additional outputs. So instead of having a battery that you can't really do anything with, you can use this as a standalone power station, or when you add it on, you can double the capacity and get the additional outputs. Now, speaking of the cons, a power station of this price will usually have a few bugs, and I did find a few as I was doing all my testing. For example, when we tried to get the smart app to connect to Wi-Fi on my home network, it did not work, and I would definitely recommend ALLPOWERS updates their smart app to be a little bit more intuitive. Now, when it came to the smart app, I also tried to adjust the standard charging speed to fast charging speed, or fast mode, and I did not notice a difference when using the main unit increasing the charging wattage. It was still around almost 900 watts on both settings, so it was kind of interesting that fast mode didn't go any faster. Now, another thing that I noticed is whenever this is AC charging, it puts off some sort of interference to sensitive devices. For example, my camera. Now, this is not an audible noise that if you put your ear up to the power station, you're not going to hear that. But if I had my camera within 10 feet of this when it was AC charging, I heard that crackly pop noise in the background whenever I was trying to record, and it was kind of annoying. You know, I couldn't make that noise go away. So just be aware that if you have a sensitive device, an audio equipment of some sort, like a speaker or an intercom or maybe a radio, it's going to pick up on that interference. Now, the last thing I noticed when I was testing the power station, not really a huge con, but if you are discharging this with the AC inverter, it stops at 5% remaining. So that's why we weren't able to get the full 85% goal. We got 82% of the rated capacity. It's not like the inverter isn't super efficient, it's just it didn't take it all the way down to 0%. And some power station companies leave a small reserve like that whenever you're using the AC inverter, and ALLPOWERS chose to do that. So when you are discharging with the AC inverter, it's going to leave 5% on the state of charge, and then it'll shut off the inverter. And I did not notice that when you're using the DC output. If you use the 12-volt socket, it goes all the way down to 0%. Now, guys, a special thank you to ALLPOWERS for sending out the R1500 and the expansion battery for this testing video. So now you guys know how it actually performs. Now, after seeing these results, what is your favorite feature of the R1500? Is there something that you would change, or is it a power station that you'll choose? Make sure you leave a comment down below. I always love seeing your guys' feedback on these videos. Now, if you like the video, please smash the thumbs up button. I'll recommend a couple of the videos that you guys can check out if you like this type of content. And remember, guys, I'm available through a basic consulting service. So if you have questions about power stations or connecting up solar panels or even some sort of DIY setup, feel free to reach out. Thanks for watching. We'll see you guys in the next video.